Seems like we are live now.
Yes, we are live. Yeah, okay.
Yep.
Hello, everyone. Hello, TFC Chandigarh. Hello, everyone. So, how are you guys?
Hi everyone. We'll just get started and you can just use the comment section and you can share whatever questions you have while we are talking and while Usha is giving you talk. Anything that's related to LLMs or responsible AI, and we'll be happy to take them up as we go ahead. Okay. So I'll just allow Pranav to get started now.
Okay. Thank you, Ashi. So, hello, everyone. I am Pranav. So, today I will be hosting you guys on very much enthusiastic technology like AI, LLMs, and I am thrilled to be your host for today's. And I am a TFG Chandigarh co-organizer along with Ashi, who is leading a chapter of TFG Chandigarh. And we have a distinguished speaker today, Usha Rengaraju. She will be our guide on today's exploration, delving on the today's topic of unleashing the power of LLM and a guide to responsible AI for the next generation. So let me just give a brief about her. Usha is currently head of the data science research at Exa Protocol, and she is the world's first woman triple Kaggle grandmaster, and that's pretty much great. And those who are like looking for make their career in AI, they can have much questions and they can do some hands on whatever she will be doing at the session. She is specialized in deep learning and graphical model, and also one of the judges of Tiger Graph, and she's ranked as top 10 data scientist in India for the year of 2020. And also she's a AI leader and influencer by 3i magazine. So that's pretty much about it. Without doing further delay, I will be adding her in a call so we can have some great session and you guys can learn much and more thing about it. So let me add up. Okay, so I guess she's here. So hello, Usha. So
Yeah, yeah. Hi. Yeah,
session is
hello,
all.
both of you, Ashi and Pranav. Thank you so much for inviting me for this session. So, yeah, let me know when I can start.
Yeah, yeah. Sure. So you can start and you can share your screen. We will be on mute and here only. If you need any help, just let us know.
Yeah, yeah, sure, sure. I'll just share my screen. So, enter screen. Yeah. So, is my screen visible now?
Yeah.
Yeah, yeah, sure. Like, let's get started. So, yeah, today's topic is going to be more on the building responsible LLMs. So, on the security and privacy risk, particularly in LLMs. So, it may not be about how you can build LLMs. And I think you already had a session earlier with TFUG Chandigarh on how to build LLMs, and you had a coding workshop on that. So this will be a follow-up session on how you can make your LLMs more secure and mitigated from certain security and privacy risk. This session, I think, is being heavily influenced by a particular blog writer who has like now gone through multiple research papers, written down notes. So I have heavily been influenced by the slides. I have provided links to his blog, and with that, I'll give you a brief introduction of 2 3 slides on large language models. Although the topic is about the security risk, for people who have never heard of large language models, a small refresher of 2 3 slides. So, large language models are typically an AI algorithm, and it deals with predominantly text data. And you where you train huge volumes of text data. It could be from the web, or at times it could be even proprietary data or an enterprise information, but it generally involves huge training of huge volumes of text data. And these models have parameters in the tune of 100 billion and above, and that's why it's called large language models. And large language models predominantly falls under the umbrella term of generative AI. And generative AI is also closely related with both LLMs, which is generation of text, and also generation of images and generation of other multimodal inputs as well. So, this is a brief introduction about large language models, where we are talking about models with parameters greater than 100 million and above. And these models are trained on huge, massive amounts of text data. Sometimes they are open source, sometimes there are a lot of models which are trained on proprietary data as well. There are a lot of organizations like Facebook and other Microsoft, including OpenAI. They don't make their models completely licenses having a particular, it's not completely open source. Sometimes it's partially open source. Sometimes there's a restriction on using it for commercial license. So there are all kinds of different restrictions, applied on open source models, especially the big ones. So this is a brief snapshot of how large language models work. So the large language models are, as I told you earlier, are trained on huge volumes of text data, and this text data could be structured data. In certain cases, it can be like a proper from your relational databases, where, for example, if you're dealing with a financial sector and you're training, do your use cases detecting frauds using LLMs for the banking sector. So predominantly you'll be dealing with credit card transaction history of several customers, which is going to be a very structured data. So there are at times when you will be training with structured data. At times it can be just Wikipedia text, which is totally unstructured. And you have huge volumes of data from Quora, question answering, and then you also have several question answering forums which are also open source and which can be used to train your large language models as well. There are plenty of ebooks available out there. So these are some of the sources of data which your large language model could be used which your large language model could be trained on. And once they're trained on, they could be fine-tuned on a specific task. The task can be, you can fine-tune your large language models to solve a question answering problem. You can also fine-tune your same model to solve a different problem, which is sentiment analysis or information summarization or language translation. So I'm just coming from a generative AI hackathon, and some of the folks have built entity extraction model today, where you give them a real estate document, and from the real estate document, if you see any land buying document today, it involves huge volumes of pages, and sometimes it is in a language which we do not comprehend. Sometimes it might be in Hindi, although being a national language, may not be understood by many people down south. And so if you want to extract the very important parameters from the document, then you can use named entity extraction to extract the very important parameters from that document. So this was one of the projects which was developed by one of the folks today. So there are multiple use cases. So retail assistant, shopping assistant, which can help you with question answers, or legal assistant. So these are some of the question answering bots which are available, which is based on LLMs. And sentiment analysis. So whether you're an e-commerce provider, or where you're selling huge amount of products for cross domains, you really have to understand the sentiment of people. So these days large language models are used for doing sentiment analysis as well. Of course, and the language translation is one of the very important use cases. All of you might have heard about Open Hadi model. So it is one of the large language models which is released for Hindi, and which is making quite a wave. And the startup which has released its Sarvam AI has got like whopping like 42 million funding, and so there's a lot of buzz around. Even I think a couple of days I read about Ola's founder releasing a large language model for Bharat LLM and stuff. So there's a lot of buzz about they're building large language models for Indian languages, which can translate into one Indian language to another Indian language. This is very, very important and need of the heart, because the large language models which are currently outperforming and on top of the leaderboard do not particularly perform that well with Indian languages. So we need more large language models which are specifically fine tuned on Indian languages, which can perform better. And so there are a lot of use cases around language translation as well, particularly. For example, if you take a lot of course videos from IIT, this is a project, real time project, which is happening, which is leading academic institutions are part of it, where there are a lot of videos in English. But if you want to democratize knowledge, you might have to translate that language into a lot of Indian languages as well. So there's a live project taken over by multiple IITs where they take the Neptune videos and they, do a translation of it to multiple languages like Hindi, Tamil, and other regional languages. More than 250 projects. This is a live academic project which has been done in India. So there are a lot of employment of large language models, particularly in the translation space, um, amongst the Indian languages. So, to summarize some of the very, very standard use cases of large language models, they used as retail assistant in retail showrooms. And some of the less known applications of large language models or less discussed applications of large language models are its usage in the life science research. So understanding a lot of RNA data or understanding a lot of DNA data is particularly very, very complex, and it can take even an experienced genomics. It might be very, very overwhelming, and it takes a lot and lot of research and a lot of time to come up with analysis and explanation for a lot of things in that domain. And large language models are currently empowering the genomic life sciences research. And this is very, very important because there's no one size medicine which fits for all. You require the research in the medical field, particularly life sciences research, are focused more on providing, based on your genomic blueprint, prescribing you a specific medicines based on your genomic blueprint. That is a space where we are heading to, instead of prescribing a medicine. If this is the symptoms which you're having, then this is the medicine. This was the case till now, but then right now the life science research is changing, so we are moving towards a direction where for your specific genomic blueprint, what kind of medicines you can have. So personalized recommendation of medicines is a space we are heading towards. And I mean, large language models are used in anomaly detection, fraud analysis, and it's also used in marketing for customer segmentations. And legal domain is one of the domains which has been a huge hit, where large language models are used for paraphrasing, summarizing, legal assistant. So these are some of the use cases of large language models. This is a snapshot of evolution of open source LLMs. So I might have skipped some of the LLMs here because I'm not. This week was I've taken this slide from one of my different workshop which I used to do for LangChain, and so that was prepared almost a year back, almost like 8 months back. So the snapshot was quite old, maybe 8 months back. So this doesn't have the recent list of models which has come. But this shows an evolution of models up to mid 2023. And so, we started with T5. Flan T5 is still considered to be a moderately sized language model. And this is, you'll find a lot of logos from Google, DeepMind, Microsoft, OpenAI, and Hugging Face, Meta. So these are some of the most these are some of the providers which release large language models at much more frequent at much higher frequencies, and the models which consistently perform really well on the leaderboard coming from some of these organizations. So this is kind of the evolution of space. So the most famous model, chat gpt, was somewhere released in November of 20. You can find ChatGPT there somewhere. It got released between November 2022. And yeah, I think even if I travel to some very remote parts of the country, so I was just traveling to Kerala, and last I think 2 months back, and I met a person who told me like he's something who's very remotely connected to computer science, or who's remotely connected to anything technical. But then I asked him if he knows ChatGPT or not. He said yes. So even people who don't have anything to do with technical or anything to do with code or anything to do with computer science, they still know what ChatGPT is. So ChatGPT is definitely something which is phenomenal, and it had a great penetrations to everyone's walks of life. And yeah, so this is a brief introduction about LLMs. So coming to the main topic of LLM, so this introduction is specifically for people who don't know what large language models is and who's taking the session. So this is a brief introduction for them, or who have missed TFUG Chandigarh's previous session on LLMs and workshops, then you might have some context of what large language models is. So now that we have covered what large language models is, where it is used, what are the applications, and how it is being built, let's go to the main topic for today's session, which is security and privacy risk in LLMs. So we do, there's a lot. If you see Nandan Nilekani, he is given a couple of days, but I think must be a week. I'm very bad with dates, so you might have to verify whatever I say. So a week back, I saw one of the interviews of Nandan Nilekani where he was saying, please don't focus on how big, please don't emphasize more on the size of your model or where it tops on the leaderboard. Focus on the use case. That was what he said. So there's a lot of emphasis on being on top of the leaderboard, being at the top of the hype curve and all that, but there is less and less emphasis on security and the privacy risk. We don't discuss these very important topics as much as it deserves to be discussed. So this is a very, very important topics, and there should be a lot more focus on the security and private risk. Because if we do not discuss such essential topics, then it could lead to a lot of damage, and it could have really, really worse implications on everyone's life. So some of the risks which are involved with LLMs are data leakage, reverse engineering of source training data, and generation of incorrect content. And you also have harmful content generation. These two are slightly different. Generation of incorrect content is mostly generating some content which looks like more believable, but it may not be actually accurate. Generation of harmful content is more like generating content which falls under the category of hate speech and violation of certain rules and regulations, content violating certain rules and things like that. Prompt injection, so you can modify or manipulate your prompt to make your large language models generate an incorrect content. So this, and there are multiple techniques around prompt injection. So this is one of the very, very important security risk around LLMs. And there are a lot of hackers and attackers who will attack different stages of your model. They can either attack the model training process, or they can attack the model deployment process, or they can attack the phase when the model is being used. So at the multiple stages of the model, the attack can happen. So it is all of this falls under unauthorized access to the model. And compliance, regulatory incompatibility is more around the lines of there are a lot of organization. I think last 2 weeks back, around 2 weeks, in the vicinity of 2 weeks, there were laws which was passed by Europe, and there were a lot of feedback and reception regarding the laws passed by the EU government around the usage of AI. So there are certain geographical locations who have strong laws against how AI has to be used, how data has to be used, how the data governance has to happen, and all of this. And so it's very, very important to comply to these regulations. For example, if you take US data, so where you cannot move US database which contains private and sensitive information about US citizens from US to any other geographical location. If you do that, that's going to be under heavy penalty. I think some of the famous companies have done that. They moved the data out of a different geographical location, and they ended up paying huge penalty for that as well. So these are some of the violations against the regulatory compliances. So it could be different forms of regulations, and different geographical locations have got different regulations. It's very, very important to comply to these regulations. And next is the insecure. Like these days, large language models are also used in code generations. There are a lot of foundational large language models which are like fine tuned for code generations, like the famous ones like Star Coder and all that. So all of this leads to insecure code gen creation. So it's very, very important to have secure practices around code creation. And the most important topic which we will be discussing today is about deepfakes. So even Modi recently was commenting about deepfakes, and he was saying it's one of the biggest threats. I'm not sure exactly. I think it should be within a month of Modi giving an interview that about deepfake, saying it's one of the important threat for India. And there's a lot of Indian organizations, including Indian Army and Indian Navy, and all of them have been working on deepfake detection for quite some time. It's been a threat to a lot of nations. And you might have all seen a dancing video of Obama, or a video of Obama speaking certain context, and which went viral, but that was not spoken by Obama at all. So that was video was generated by some harmful people with harmful intentions. So there are a lot of, at times, these kind of deepfakes may be funny, or maybe generated with a light-hearted intent, and it's it's harmless. But there are at times where a president of a country, or prime minister of a country, or somebody who is wanting to take revenge on somebody else, they could be used for negative intentions as well. So deepfakes are an important threat for a lot of people, and it's very, very important to have mitigations or steps to prevent deepfakes. So these are brief techniques under the security and privacy risk, and we will be taking each of these topics and explore a bit more on this, on how to mitigate this risk. So we'll start with the first topic. And before we start with the first topic, a simple snapshot about AI pipeline, or the product pipeline. So if you take any product which is falls under the software development life cycle, you start with particularly an AI project, AI software project. You starts with the data. So any the soul of a data science software product is the data. So you have a huge data source. It could be a relational data store or an unstructured data store. You have a huge source of data. Then you have a data processing input pipeline, and then you have a traditional application security layer. So this traditional application security layer is part of all projects. It could be AI projects or non-AI projects, irrespective of what domain it falls under. Application security layer is a very, very integral component of software development. And if it's going to be an AI project, you also have the AI component, where you have the model building, model deployment, and all of it. So this simply is a snapshot of an AI software engineering project. And there are a lot of places where threat can be introduced or injected into this life cycle. So you can start with source data, where you can you can poison the data. You can add a lot of incorrect information to the data. What happens when you add a lot of incorrect information to the data? What happens is you will end up building a model which gives you false outputs, or which gives you very incorrect outputs. So there could be data leakage, or there could be poisoning which can happen at the source data. There could also be poisoning which can happen at the supply chain level. So what these days, most of the enterprise companies, they actually take data from multiple third party vendors. So there are multiple sources for data for a single project. The data could be coming from multiple diverse sources. What if your attacker, or well, the person who's trying to attack your company's project is going to, instead of directly, of infiltrating into your company's project, he could go directly and corrupt the source, which is a third party vendor. He could get all your data from the third party vendor and do corruption at that level. So at the supply chain level, there could be attacks happening as well. And so the other parts where there could be threats is somebody can steal your model. Once they steal your model, they could get all the information about the model, and they could start manipulating it to behave in a way they want. This is a very, very serious problem. And sometimes, instead of stealing your model, they can steal your model's parameters. Again, that could pose a threat as well. And so these are places where threat can happen. It can either happen at the source data level or the model level, and we'll be learning more about these threats under various categories shortly. So the first security risk which we will be discussing is about data leakage. So data leakage is basically, an attacker getting access to unauthorized information, getting access to information which he is not supposed to get access to. So this data leakage can happen in multiple ways. So it can it can either happen because the training data itself is revealing a lot of information. It contains a lot of sensitive information which it's not supposed to have. Or a lot of times, people do not remove the sensitive information before training their model. They have the sensitive information along with it, which will reveal a lot of information about the model, and they could trace back to the original input and start correcting your model. So, sanitizing your training data is very, very important. And even today, one of the projects I was reviewing was about a banking project, where the person, I asked where did she take the data from, and she said she downloaded the data from a banking website. It was a sample data, and she has used trained the model and the account number of the individual. So she has trained the model on a very, very sensitive information. And so these kind of training might lead to data leakage. And a very famous example was, there was an open source data which was released by I think it is Massachusetts. So one of the states in United States, they have released a data of very personal information. And they you know they they thought they are releasing an anonymized data, but they did not anonymize it properly. So the attackers from MIT were still able to infiltrate the data which they released by mapping it with another open source data set which was available, and they were able to particularly map which row of data belongs to which particular individual in that particular state. So they were able to trace back successfully to what are the healthcare records. I think this was healthcare records of patients from a particular state. And they anonymized that they thought they're releasing an anonymized data, but they did not anonymize properly. And so the attackers were able to map it with another open source data, and they were able to exactly identify every row of the particular data set belongs to which individual. So it's very, very important to anonymize data to not leak any unauthorized information to the attackers. So it's very, very important to sanitize the training data, and also use privacy preserving training algorithm or approaches. So when you take privacy preserving approaches, there are multiple privacy preserving approaches out there. You have differential privacy, you have homomorphic encryption, you have federated learning, you have secure multi-party computation, you also have knowledge distillation, and then finally the synthetic data generation techniques. A brief one liner of all these privacy preserving approaches would be, see, for differential privacy, It basically boils down to adding noise to your data, so the people cannot figure out what the original data set was, or people cannot find out who that record of data belongs to which individual person. So anonymizing and adding data noise to the data in such a way, it is completely it is foolproof, or you cannot trace back to who the record to an individual identity. So this is what this is about the differential privacy. And when you take homomorphic encryption, before you start training your data, encrypting all the model input values or encrypting all the model parameters revolves is about homomorphic encryption. And federated learning and security multi-party computations are both similar techniques in a way. Similar techniques in a way is federated learning is more around machine learning, and secure multi-party computation is more around encryption and cryptography. So if you take federated learning, there'll be different providers who will be training the model on their own private data. So these different providers will not share their private data to each other. But in secure multi-party computation, what you do is you use cryptography and compute a certain function on using their private data. And this private data is not, shared among multiple stakeholders. And then there is knowledge distillation. So knowledge distillation is more about, you training a large language model, and then taking the output of a large language model and feeding it into a smaller model. So you're not directly feeding the using the training the smaller model on the data set directly. What, instead of training the smaller model or the final model on the data set, you train a large model on the data set and take the output of the large language model, and then use that to train a smaller model. And in that way you do not have direct access to the original data set. So this is about knowledge distillation. And you also have synthetic data generation techniques, where you actually try to generate a similar data set from your actual data set, which has a similar probability distribution. So that way, nobody will know what the real data was. So these are some of the privacy preserving approaches. I've described these approaches in a more informal way, in an intuitive way, but these approaches also have a specific formal definition, which I would definitely recommend looking up the corresponding research papers to learn the formal definition of these techniques. But what I've just covered is just a very intuitive understanding of what these techniques boil down to. So this is the data leakage is the first privacy risk which we have discussed, and there's also another second risk, which is the reverse engineering of your source training data. So reverse engineering is breaking down your process into a smaller subtask, and then figuring out, understanding the ins, bolts, and nuts of that smaller component, so that you can crack down the entire product. So this reverse engineering can be done on your source training data as well. And if attackers do reverse engineering data on your training data and get the information, unauthorized information, which they are not supposed to have access to, then that can lead down to the breakdown of the large language models, and that can also lead to several poisoning attacks. And so it's very, very important to safeguard your training data from any reverse engineering or any poisoning attacks. So this is going to be the second security and privacy risk which we are going to discuss. So now that we have seen what reverse engineering is, can see what are the steps we can do to mitigate reverse engineering. So some of the steps which we can do is anonymization of data, or data obfuscation, which means healthcare records are generally removed from all the name, ID, and all these sensitive information of the users are removed from the healthcare data before they are used for model training. Or there are at times where you cannot actually remove sensitive information completely. It might be a very critical parameter to model training. So those cases you can actually replace it with a synonym of that particular value. So an attacker can never really know what the real value was, even if they try to attack the model at some point. So deploy different privacy techniques, which means just don't follow a single privacy technique like federated learning. Follow multiple techniques, so an attacker might find it impossible to find out the combination of techniques which you have used to encrypt your model and your model parameters and training data. So always use a diverse portfolio of techniques, so it's very very difficult for attackers to penetrate into your system. And data can be aggregated at the same place. Don't have a single source of data. Your data collection strategies ensure you are collected from multiple aggregate or diverse data sources, so that even if attacker gets hold of some of your data sets, there are still data sets, he may not have the complete access to all of your data set points. That would delay the attack to an extent at least. So always ensure you can collect your source data from diverse set of sources. And it's also very important to protect your model. So model protection can be either placing your model in a very secure place, and creating a secure security layer where the attacker cannot that easily penetrate into, and ensuring all your model parameters are encrypted with a secret key and things like that. So have robot data handling pipelines and practices. Have an input data pipeline where have validation checks, and you ensure poisoning attacks cannot happen at the data pipeline or at the data source level. Limit the model outputs. So there's a lot of poisoning which happens through prompts. So if you can build a validation layer at that phase to prevent what kind of input parameters or what kind of model parameters goes in there, then you can also have a control over your model outputs. So limit your model outputs, or have a validation layer around your model outputs, and also educate people around the ethical guidelines and principles of data usage. So these are some of the techniques, mitigation techniques, which can be taken for mitigate for against a reverse engineering of your source training data. The third technique which we will be discussing is about the incorrect content generation. So hallucinations is one of the the most famous term, which is a synonym of this is hallucinations. So hallucinations has always been a biggest threat for LLMs. So all your famous models like ChatGPT, Bard have all suffered the problem of hallucinations. So we cannot, at this point of phase, there's no way we can completely eradicate this problem. There is always set of steps which we can take to ensure we mitigate these risks. So you can use high quality training data set. So it's very very difficult to get a high quality training data set, but whatever way possible, we can ensure there's different validation strategies or layers applied at different levels to ensure the final training data set which we use for model training has is at least known to us. There is no bad values or parameters or corruption or poisoning which is happening at the data source. So ensure whatever possible ways you can apply validations to your input training data. And train your data on a very small task specific data set. The more generalized LLMs may not necessarily perform very well for a very specific task. So fine tuning is required on a very custom data set to perform a very specific task to avoid hallucinations. And there is also a process called context stuffing. So most of the times LLMs hallucinate because they are not aware of the context as well. So try to focus more on increasing the context awareness, and by feeding it with information which is required to generate a very relevant output. And this process is called context stuffing. These are some of the recommendations to eradicate hallucinations, but that being said, we are not in a phase stage where we can completely get rid of hallucinations. It's a very glooming threat for LLMs, but we can take in certain measures to reduce their reduce their harmful effects and things like that. So the next privacy risk which we will be discussing is about model bias. So most of you would have watched that Netflix movie from Joy Balami about how a security software was having a very uh, you know bias around people from certain geographical locations. So it was not allowing black people, or it was not recognizing black people, and it was not always recognize categorizing black people into a certain category. So this was spotted by an MIT graduate student back then, and the whole story was made into a Netflix movie as well. So, a lot of models and LLMs, not just LLMs, machine learning models and AI models have bias ingrained into them. So LLMs also have a lot of gender biases and other forms of biases which is deeply ingrained into them, and it is very important to ensure or take steps which will mitigate these model biases. So, in order to mitigate model biases, you'll have to first understand what the biases is, what the root cause of is, and all of it. So, you might have to perform a root cause analysis, and that's all possible if you understand your model better. So to understand model biases, there are a lot of open source tools right now, and some of the open source tools which we have at our disposal is AI Fairness 360, and this is from IBM Research, and you also have What If tool from Google Research, and you also have FairML, which is all of it is open source and which is available for you to understand model biases. Once you understand model biases, that is when you can start taking measures to mitigate it. And some of the steps where you can mitigate model biases is having a diverse training data, and you can perform a bias aware fine tuning, user feedback, and you can have continuous iterative improvement. And you can also have when you uh, make your model open source and then start getting feedback from a lot of people, that will also help you improve your model and remove the biases which is deeply ingrained in your model. If you see a lot of academic institutions, particularly Stanford, they would have released a lot of large language models. They would have made it open source, particularly to get the feedback from the global community, so that they can help, so they believe that that can help them eradicate the model biases. So not just Stanford, there are other academic institutions who do this as well. So these are some of the mitigation strategies which are recommended to help remove model biases. So and the next topic is about the harmful content generation. So this is slightly different from incorrect content generation, where here again we are generating a content which is not really what is expected, but here it has a very harmful effects. Like you can end up generating content which spreads malicious information or hate speech and things like that, which can have extremely harmful effects. So it's important to take some steps to mitigate this risk. And some of the ways which you can do that is to train your LLMs on filtered dataset. When you mean filtered dataset is applying several validation rules and carefully evaluating all the features to ensure it does not feed any incorrect content in any indirect way possible. So, training your LLMs on filter data sets to a large extent can help save your model or mitigate the risk of generating harmful content. But it's not as easy as it sounds. This is a very complex process. And there are a lot of research papers around it. I would definitely recommend digging it out. and also using tools to detect the harmful content in LLMs. So, to help you ease the process of detecting the harmful content, you also have a lot of open source AIs. I think it's predictable AI or something. I'm not sure exactly of the open source API which is available, which can help you detect the harmful content, and also educating the users about the risk of LLMs is very very important. And so these are some of the recommendations to mitigate the risk of harmful content generation. And the next topic which we will be discussing is about the prompt injection. So there's a lot of malicious attack which can occur, particularly around prompt engineering, and about manipulating your prompts to have an incorrect model behavior. So this manipulation of prompts can happen in two ways. It can be one in an active way, and the two in a very very indirect way. So if you say active prompt injection, it is about directly giving some kind of incorrect parameters to your prompt to manipulate your model output. So that is a very direct way, also it's called active prompt injection. So there's also an indirect way of doing it. That is, instead of manipulating your prompt parameters, you can go and make your model generate the output, then before the user could get access to your model output, manipulate that output and display a very false output to the end user. So manipulation can either happen directly or indirectly based on what kind of medium you use to poison your prompts. It's called active and indirect mode of prompt injection. So some of the ways you can mitigate this risk is using a secure LLM provider. So be very careful about the model you're using. It could be an open source model or it could be a custom model. Ensure you're using a secure LLM. Ensure your prompts are very, very secure. Just don't give any random prompt. Hand check every prompt. Don't use any prompts which you do not know or which you have not personally written. So ensure you always use secure prompt, and monitoring your output. So having a validation layer at the model output before displaying it to the end user is also a very good practice. And also you can have a secret phrase, so somebody who is giving a prompt without that secret phrase, you can identify as some attacker. So every legitimate person who is using prompts to should use that particular secret phrase, or it's some kind of a two-factor authentication model. And you can also, instead of using prompts, you can also use parameterized queries as input to your model. So that way there's no way an attacker will exactly know what the parameters you have to feed as an input to your model. So, and also having similar to output validation, you can also have an input validation layer. So these are some of the steps which you can take to mitigate the risk of prompt injection. And again, an attacker, a very skillful person who can who wants to attack your model, can attack the model training process itself. Instead of poisoning your prompt, he can directly target your model. So you can either target your model's training process or deployment process, or he can model usage steps. He can attack or try to poison the different phases of the model. And some of the steps where you can take to mitigate this risk is having secure passwords or strong passwords and two-factor authentications. And some of the places where vulnerabilities gets introduced is when your softwares which you're using, particularly it could be the programming softwares or the libraries which you're using to train your model, is not up to date. This is one of the places where there could be vulnerabilities which can be introduced into the process. Also have a very strong application layer security for all of your AI product, and a traditional application security layer ensure that is incorporated before you ship your product. And so always have a monitoring software which will monitor for any unusual activity in your entire product pipeline. so that you can identify the risk at an early stage itself. Always have, see, the attacks are bound to happen. So when the attacks happen, what are you going to do? So one of the steps which we need to is to roll back to a state where it was proper. So we may not be always able to save a product 100% from the attacks, but what we should also have is a plan B where we roll back to a state where everything was proper. So these are some of the recommendations to mitigate the risk of unauthorized access to your models. And there's also compliance and regulatory incompatibility. So every geographic, there could be certain models which could pass off as legal in India, but might not be able to pass off in Europe. So Europe has got very strong regulatory compliances, and so there are a lot of compliance regulations around model being interpretable, and also model having explainable layer incorporated. So there are strong guidelines on how you should build your machine learning model in certain geographical institutions, regions, and sometimes it can be very country specific. So US may have different data regulations compared to UK, and Australia might have. So every company has got different legal requirements, and India also has been trying hard to build around some legal regulations around AI, but it's a very very complex process. So, some of these steps which you can use to mitigate around incompliances is just being transparent about how the model was trained, ensuring your model follows fair practices, protect the privacy of data. And so, these are some of the steps which you can take. And there's also there are a lot of these days, large language models are used for code creation as well. So there could be a lot of poisoning which happens in code creation as well. You can generate code that's not secure, which is very difficult to test. Sometimes it's intentionally insecure as well. So some of the steps which you can take to mitigate this particular risk is to have a security scanner, to have an expert reviewer for code review, and you can have very security focused testing process. So there's a lot of security around model training process, there's a lot of security around input data, validation of data and all, but there's not much of an emphasis around security around testing process. So there could be a lot of focus on that area as well. So these are some of the recommendations to mitigate the risk around the insecure code creation. And the final topic which we'll be discussing today is about the deepfakes. So deepfakes requires no introduction. It's a very, very popular topic amongst a lot of people. So deepfakes is about creating very harmful content. It could be either mimicking a particular individual and having things said, or videos created, or image generated. Even there was, I think, couple of months back, there were pictures of a particular South Indian actress which was released, which was, I think, Rashmika Mandana. I think she's the heroine of current movie Animal. So there were pictures of her which were released, which was not actually pictures of her. They were photoshopped. So deepfakes can take multiple avatars. It could be audio, video, and it could be images as well. It could take multiple modalities, and it is always a very very serious threat which could create a very very severe impact on the individuals involved. So it's very important to take certain steps to mitigate this risk, and always educate people and train people about defects so they can spot it early on. And don't believe everything which you see. Always have a suspicious eye. Always have a thought that it could not be true. It could have been generated, or it could have been manipulated. So always be suspicious about something which you see, which is really something which is not so common. And always take safe security measures, have strong passwords, and be educative about the current advancements in these fields, so that you can take measures which are necessary. So these are some of the security and privacy risks for LLMs and some of the recommendations to mitigate. And following up all these recommendations can help you build a more responsible AI, which can have more impactful impact on everyone who's using your product. And so this is about the end of the topic. To summarize, the list of privacy risk which we discussed, we talked about data leakage, we talked about reverse engineering, we talked about hallucinations or incorrect content creation, we talked about model bias, we talked about harmful content creation and about prompt injection, how people and attackers get access to your unauthorized access to your model, be it your model itself or your model parameters. And we also talked about the compliance, incompatibility, how poisoning can happen at the code creation stage, and finally about deepfakes. So these are some of the privacy risks, and we also discussed certain recommendations to mitigate these privacy risks. So with this, we have come to the end of the topic. And so I'm supposed to take for 45 minutes. I never thought this topic would extend for 55 minutes, because it's like a very theory topic, and I generally don't do that much of a theory session. So yeah, I think I filled on for a lot of time. Yeah, over to Ashi and Pranav.
Thank you so
Thank
much, Usha, for taking this up.
you, Shah.
Yeah.
And we have lots many questions. Pranav, let's just take questions. We have around 5 minutes.
Yeah, sure. So we will be highlighting few questions, so we can, I guess, answer those. So first question is from Shuchi. It's related to: is it necessary to master deep learning to use LLM? So can we answer that?
Okay, most of the large language models have, I think, at least very standard models have got transformer based architectures. So, to have a deeper understanding of it, I think deep learning is very, very important. That being said, it depends on in what context you want to use large language models. So, are you a business user? Because I have taken classes even for MBA students at IIM Ahmedabad and Bangalore and all of it. They don't even know single line of coding, but they still use prompt engineering and all that. So it depends on what context you want to use large language models. Depending on that, you might, if you're going to build your own custom model, or if you're going to fine tune it for a specific task, having an understanding of deep learning process and pipeline might really help.
Okay, thank you. I guess, Shuchi, we you have your answer now, so you can start jumping on it. Now we have another question from Lavleen, which is highest privacy risk in LLMs?
Yeah, I would highlight a combination of risk. It could be, data leakage, and it could be unauthorized prompt injections and unauthorized access to your model. And so, yeah, these are some of the highest risk, because having an unauthorized access to an enterprise LLM, which is built for specifically, because I was giving a training for a particular hardware provider, particularly it's a GPU manufacturer based out of Malaysia. Just last week I gave a corporate training. So I was doing an LLM workshop, and I was asking them to train. I was giving a end-to-end use case of how to do a particular task, and then I told, instead of using this PDF, use your internal PDF or something, or test it on your own data. So immediately there was a person who put in the chat window, do not use any security or privacy documents of our company. So that is because, once you train your model on it, most of the companies, organizations have their own internal LLMs and generative AI, which their employees use. And these are trained on their very security, highly private documents. And when attackers have access to these model parameters or access to these models, then the competitors can get to know everything about that company. So there's a lot of risk which is involved as well. I think there was Samsung incident which recently happened. There was one of the Samsung AI research lab in Bangalore. One of the research scientists, he actually gave certain prompts to OpenAI, and these prompts contained information about a very important patent for Samsung AI research. and because of it, Samsung AI lost out of the patent, and then they banned all the employees from using OpenAI ChatGPT. And so there's a lot of risk around prompt injections and unauthorized access to the model data leakage. I think, I mean, in my limited understanding of LLMs, I could highlight these things, but somebody, a researcher in this field, might give you the actual correct answer.
Okay. I hope, Lavrin, we gave your answer. Thank you, Usha, for that. And we have another question related to hallucinations. That how can I reduce hallucinations in LLM by Praveen?
Yeah, I think we can take certain steps which can reduce the hallucinations in LLMs, like focusing on having a filtered data set. So having certain validations incorporated on each features of your input data, ensuring your input data is anonymized, and also having a validation layer on your model output. And so then training it for a very specific task. If you take a generalized LLM, which is performing really well in English, maybe if you're testing out on language translation task, and if you test it on an Indian language, there'll be a lot of hallucinations because it's really not trained on an Indian language data set. But then if you take a more specific models like OpenAI, which is trained on Hindi language, it's just a Hindi language model, they might perform better with tasks around Hindi translation from one language to another language, or any of the, even it could be named entity recognition in Hindi, they might perform really better compared to Falcon 7B. If you do named entity recognition on Falcon 7B on Hindi data set, they may not perform really better. So fine tuning for your specific use case on your very custom data set can reduce hallucination to a larger extent. So these are some of the recommendations, but we are still in the phase where there's a lot of research happening in this, and we're all striving towards achieving, eradicating this. So yeah.
Okay. Thank you. I hope, Praveen, you got your answer. And we have another question from Vrinda, which is related to highlight instances synthetic data significantly enhanced machine learning model performance and robustness. So she want you to highlight some sort of instances where synthetic data enhanced can be more robust, and I guess that's her question. So
Oh, yeah, sure. See, one of the use cases I would say is healthcare, because I've specifically got some experiences around healthcare where getting getting data for certain use cases is very very difficult, because a lot of patients don't agree for using their data for model training purposes. And so healthcare is one specific use cases. So these places where you can give assurance to the patients that you're not actually going to use their data, but then you're going to create a synthetic data from the original data, and only that synthetic data is used for generation, might to an extent help you create a data set for a lot of use cases. Because there are a lot of use cases where AI can be efficiently applied, and there were small level tests which were performed by MIT and other universities, which were quite successful in solving certain healthcare use cases, but they've still not been openly accepted or adopted by hospitals, because only reason because they don't have a benchmark data sets for that particular use case. And a lot of patients who are very very reluctant to use their own personal data for training. So there are a lot of use cases in healthcare where synthetic data can play a huge role. And so that is one of the thing which I would like to highlight. But there are multiple, I mean, synthetic data generation is used in multiple places as well. So healthcare is just what I'm highlighting because I have more worked more on that particular domain.
yeah. And healthcare is one of the most like leading industries where we are using right now these things. So yeah,
Yeah.
so that's a great example. Hope Vrinda you got your answer. And I guess we cannot take more questions because we are running over time. And if anyone have any question, like whatever you have, if you want to connect Usha, then you can connect Usha on her social media. She can share like LinkedIn or Twitter or any other handle where they can reach you out, and you can answer their questions for future. So
Yeah.
is it okay if you can share?
Sure, sure. You can always reach out to me in LinkedIn and Twitter. I'm active on both these mediums. And you'll find all my email ID, everything listed out on LinkedIn. So feel free to reach out to me. But this is really not my area of specialization. I had done this topic because Aji had requested me to do so. So I'll try my best to answer your queries. And if I'm not able to answer, I'll definitely route you to the right expert. And thank you so much, TFUG, Chandigarh team, Ashi, and Pranav for hosting me today. It's my pleasure doing this talk.
Thank
It's
you
our
so much for
pleasure to have
taking
you.
time out.
Yeah,
Thanks a
yeah.
lot.
Thank you so much. Yeah, have a great weekend ahead, and catch you all in
Okay.
Udaipur. Yeah, bye bye. Thank you so much for the audience.
Sure.
Yes.
Bye-bye.
Thank you so much, Usha. And thank you everyone for joining in.
Thank you everyone for joining TFC Chandigarh. Stay tuned with us. Follow the our actual meetup group where you can find the latest update, upcoming and whatever sessions we're going to have on. For sure, we will having the offline sessions as well, and we can uh, go there and we can yeah. So if we have any feedback session, Ashi, you can share, and they can
Yeah.
for sure follow those.
Yeah. You can always reach out to us on our social media. We're active on LinkedIn, Twitter, Instagram. So if you have any kind of technologies or things that you would like us to take up sessions on or get some experts for you to understand those technologies, so we'll be happy to cover that up. So just ping us anywhere on the social media and we'll be happy to take up. Thank you everyone for joining in today.
Thank
I
you
hope
everyone
this
for
session
joining.
was informative and
Yeah.
we'll see you next time. Thanks, Pranav.
Thank you. Thank you, Ashi. Bye bye.
Bye.